Yeah, sorry, I got disconnected earlier when we were discussing this problem, and I don't know where did it disconnect. So it was still not working when we were using a new config file with a spacey. So it was still not capturing MIT as a stock name. So now I have added more examples here. So now it's definitely due to the training data set and not the config file. So now I'm adding few more examples. So earlier I had A, B, C, D here in caps. So now I have kept it in small cases. So as I have discussed earlier as well, so we have to add all the patterns we are expecting in our data set. So since I was passing MIT in small characters, I think that is due to that. It was not able to capture. So now I have added it in small as well, and few more examples. T, 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 LMNT as stock names. Also, so if we are, so in our case, if a stock name can be more than a word, then we need to add those examples as well. So for example, instead of MIT, it is MIT Private Limited. Then, and if in our training data set we have added a stock name, all the example that we have added for stock name are just one word, then there are high probability that from MIT Private Limited, it will just pick MIT as a stock name. So if a stock name can be more than 7 words, 6 words, 5 words, I think we should add all those examples in our training data set. Okay, I have added this now. Let's train our model again. Rasa. I hope I'm making sense and it is clear to everyone. Cool, model trained, saved. Let's launch our model Rasa Shell NLU. Cool. Okay, so ready to take a sentence. Can you buy 30 shares of MIT? Let's see what it displays. Shares MIT is still not picking up. What did it pick up? 30 shares into ranking. Can you buy 30 units of MIT? 20 units of MIET. Oh, yes. Okay. Okay. Now, as you can see, now it is able to recognize MIET as a stock name, as we have added more examples. So we don't have exact word in our train data set, but we have a similar word KIET, and now it is able to pick this up. Okay. So we can keep refining our training data set. And one more thing. So we have built our machine learning model enough to recognize entities and identify intent. And to make this model production ready, so we need to do a couple of more things. For example, we can parse this JSON and create a formatted CSV from this, which can give me like my sentence ID. For example, I have thousands of audio communications now, so I can take all those thousand communications from my model. So before that, I need to split all those communications into sentences. So I'll break that into sentences. Then I'll pass through the model, and once I receive the response will be JSON for each sentence. So I will pass this JSON, fetch these things, entities and intent, and then add that back to the CSV, the one that I passed. So this is the way we can like make our solution more robust and easy to read. Also, so it's not always that we always build machine learning models. So we can also make it hybrid model. So for example, here you can see we have used ABC as a beneficiary in one of our sentences. The first sentence in payment section. And let's say I pass a sentence, can you buy 30 units of ABC? So there are chances that ABC is detected as beneficiary. Did you get it? Because same entity has been tagged in my training data set as beneficiary and stock name both. So it can be detected as either of these two, right? So we can create a rule-based layer as well on top of my machine learning model. For example, we have a company name. Let's say my sentence is detected as order, I mean intent wise, and in the same sentence it has detected a beneficiary. Then we can say it's not beneficiary, it's a stock name. So we can replace beneficiary with the stock name. So sometimes we need to create this kind of rule-based layers as well on top of our machine learning model to make it production ready. Am I making sense, guys? Or anyone has any questions, please let me know. I hope all is good.
Yes, sir.
Cool. So this is our natural language. This is our NLU, natural language understanding model, and we were using RASA for this. And just to give you a little more background about RASA, so some of the companies, not some of the companies, even I have used RASA to create a chatbot. So apart from NLU, it has other components as well, as we discussed earlier, natural language generation, core SDK. So we can leverage those things to create a chatbot. And to build a chatbot, it has two components. One is natural language understanding and generation. So we have already covered natural language understanding, and that's the and you can use NLG for the half of the pipeline. Okay, so this is it about intent classification and entity recognition, and I think now we can move on to building a text classification model from scratch, and it is related to the first problem statement we discussed, that we have a lot of email and audio transcriptions from our client, and we want to check whether it has something that these guys should not have discussed, whether it has some obscene language, whether it has some risky content like people are discussing about price manipulation, or there is some kind of collusion is happening. So all the bank reviews their communications from the perspective of risk breach, and that is uh, something very important to them, and they want to build a model so that they can review all the documents. So in 10th, let's say they are receiving 10,000 communications, and all of them might not have that risk content. So probability is like out of 10,000 will have only like 10 or so, right? But we are reviewing all those 10,000. So we just wanted to remove all those communications from these 10,000 that are basically rubbish. I mean, that we don't need to review at all. So for example, in companies, we receive a lot of blanket emails as well, some newsletters or some meeting invites. So there are very less chances that they have some kind of risk breach. We have some kind of risk breach in those emails. So we can build a model that can eliminate all those emails from the entire lot, right? I think, and to solve this problem, we can build a text classification model. Okay, so let me share an Excel with you just to give you an idea what our pipeline look like, what is basically the flow of building a model. So first of all, we'll collect the data set. So for example, in my case, I collected data for last 3 months. So I picked up data from July to September 2020. So I was building a model on audio communications. And we can build on, we have built on email communication as well last year. So currently I'm building one on audio communications. So first we transcribe these audio communications using Microsoft Azure Stack. We can use Microsoft Azure to transcribe your audio communications. So Microsoft Azure provides very high accuracy in terms of transcription. So we have been using this service for a couple of years now, and we are very happy with this. So we, first of all, will transcribe all those communications into a CSV file. Then, okay, since we have like lot of communications, so we don't need to train our model on all the communications. So we can train our model on the latest data set. So I picked up data from July to September 2020. Then we'll have to do some data cleansing exercise as well on this. So we'll be removing some of the contents that are not required to build a model. So guys, are you familiar with these terms, train, test, split? I am assuming that you might have heard about these things in last couple of days during this program, your FDP program. Is that, or do you want me to explain all these things? Yeah, can you hear me?
Yes, you're audible.
Yeah, no one is replying. Okay, so I will pick up. So I need to decide on the time period first, that for which time I want to perform the exercise. I'll perform data cleaning. Then I will split my data set into train and test. And I am doing this because, so whatever model I will create, I want to test its accuracy as well. So whatever data, let's say I have 50,000 records or 50,000 audio files in last 3 months. I mean, just a rough number. So the actual number is quite big. But let's say 50,000. From 50,000, I can say I'll take 80%, 40,000 rows to train my model, and then rest 10,000 I'll keep to test my model's performance, right? Then the next step in text is, so to build a, I mean, to apply any machine learning algorithm on your data set, your data needs to be in a structured format. So when I say structured, it means table. For example, I have 3 columns in my data set. Let's say call ID, time, I mean duration, number of people the call, or duration and time of call, whether it was in evening, whether it was in night. Yeah, something like this. So if my data is in this format, then I'll call it's in a structured format. 30 seconds, 60 seconds, number of people, 2, 3, 4, time 9:30 or 8:30, something like this. This data is in a structured format, and I can apply my machine learning model on this kind of data set. But since we are building our model on transcriptions, so what I have is, instead of this, in my case, what I have is call ID text, the transcribed text, and I have a column called context. So this is it. So I have these 3 things in my data set. So call ID is my audio communications ID, text is the transcribed text. Hi, how are you? And whatever they discussed during the call. Context is my label. So as I said, so as per their old process, they have a team of manual reviewers and they review all these communications. And they have been doing this for a couple of years now. And since they have been doing it for a couple of years, so they have already, so we already have a lot of labeled data. So for example, in July, they reviewed some communications and they have marked them as context true, means there is a risk. Context false means there is no risk. So this kind of data set we have. Okay, guys, does it make sense? Okay, so our data is not structured. So because I want to use this column text to train my model. So first of all, I need to convert this data into structured format, and that is called vectorization, which is this highlighted thing. And for vectorization, we have different techniques: binary term frequency, I mean BTF, bag of words, TF-IDF. Are you guys familiar with these terms, TF-IDF and bag of words? Oh, let me see. No, okay. I'll explain. It's a very cool thing. And once your data is transformed into a structured format, then we can apply any machine learning modeling algorithm. So it could be random forest. I am hoping you would have heard this. We can use logistic regression. A lot of machine learning algorithms that you can use for this modeling exercise. Then we have step for parameter tuning. So all the modeling algorithm that we apply, so we need to pass some parameters to these algorithms. For example, so random forest tree based algorithm, then how many branch you want to create, what should be the learning rate, how many iterations you want to run. So this kind of parameters. And so you can start with their default values, but their parameters value matters a lot in terms of your model's accuracy. So you need to tune those parameters if you really want to achieve an optimized. I mean, you need to find out optimized values for those parameters to achieve high accuracy. And for this, we have a couple of algorithms like grid search, random search. Then we have model evaluation. For model evaluation, we can use metrics like AUC, ROC, confusion matrix. I'm not sure if you have heard of these terms. We can use these things to evaluate your model's performance. This is nothing but checking, how many data points were tagged as positive and how many our model was able to identify. I mean, this kind of things. And for this, we have different matrix, confusion matrix, or AUC, ROC. We can use either of these terms. Data collection, I'm sure it is clear to everyone. For data cleaning, what we do is we remove stop words from our sentences. Let me take an example. Let's say in my data set, I have two documents. One says, I'll call you on WhatsApp. And the second one is, WhatsApp has launched a new feature and it's a cool feature. Right? Okay. So the first step is, so data cleaning we do to create a vocabulary. So from our data set, we need to create a vocab, and that vocabulary will be your features. I mean the columns that we were seeing in our table earlier. So for example, I have only two documents. One is tagged as context true, other one is tagged as context false. So I'll pick up words from these sentences. So I'll create a vocab from my entire corpus or data set. And to create vocab, I'll remove stop words from my data. For example, in this sentence, I have I, will. So this kind of words do not contribute in identifying my target variable, which is context here. I mean, it will not help me identify whether there is a risk in the call or not. Is, am, are, on, so this kind of words will not contribute, and we call them stop words. So first of all, we'll remove all those stop words and we'll only keep the words that can help us identify the intent or the category of my sentence. So call, yeah, I think it can contribute. WhatsApp can be the other word. So from first sentence, I have picked up these two words and have removed other words. For example, I, will, you, on. So these all are stop words. I'll remove them. I'll just only keep call and WhatsApp. From next sentence, I'll keep WhatsApp that I already have. Has is again a stop word. Launched is another word. I think is also not important. I'll remove that as well. New can be a feature. I can use this. The other word could be feature. Yeah. Then in next sentence, it is a cool feature. So it again a stop word, is a stop word, a stop word, cool can be a identifier, I believe. Okay. Feature we already have in the list. So this is my vocab, or I can say my features that I'll use for my model training. So this will be my final table. And we will also have our last variable called context. Yes, context true, context false. So basically, we are trying to create a table from the text we have received. And this is how my final table will look like. So we have document ID 1, 2. We have all those features we have extracted and the our target variable. I mean, the class that we need to categorize our data in. Okay, now, so we have our vocab, but we need to fill in some values here in this section. Okay, and how do I do it? So there are three ways, as we discussed. I mean, there are many other ways as well, but some standard ways are binary term frequency, bag of words, and TF-IDF. We'll start with binary term frequency. Binary term frequency is nothing but to flag whether the word exists in the document or not. So for example, so these are our number of columns, and we are talking about document 1. Let's see. So our first word is call. Call exists in first sentence, yes. So I'll say 1. WhatsApp is there, yes, 1. Don't have launched here, we don't have new, we don't have feature, we don't have cool, then all these will be 0. Next sentence, we have call, no. We have WhatsApp, yes. We have launched, yes. New, yes. Feature, yes. Cool, yes. So this is one way to transform your data using binary term frequency. The other way is bag of words. So bag of words is similar to binary term frequency, but here we need to fill in the count, the frequency of word in the document. So for example, call occurs once in first document, then 1, WhatsApp also once, all these are zeros. In next sentence, WhatsApp has once, launched once, new once, but feature occurred twice, and we'll have 2 here, and cool again 1. So this is another way to transform your data set. The next method is TF-IDF, and its full form is term frequency. Document inverse frequency. We are going to use this one. It's a very cool technique. I'm going to assign weight to your words. Okay, we'll start with term frequency. So how do we calculate this? So the formula for this is number of times a word appears in a document divided by total number of words in the document. So for example, total number of words in sentence 1 are 2, call and WhatsApp, and call occurred once, then 1 by 2. So I have written a formula here. Right? So total words, words frequency divided by total number of words in the sentence. Similarly, I have calculated it for every word. So for example, we'll talk about feature. So feature is coming twice in this sentence. So 2 divided by total words in this sentence. So how many words do we have? 6. So it should be 2 by 6. Let's see if it is calculated correctly. Yes. This is how you calculate term frequency. Then we have inverse document frequency. And formula for this is log of the number of documents divided by the number of documents that contain that word. So for example, we will talk about this word call. So, so these values will be for all the documents and will not be separated by each document. So this will be for inverse document frequencies calculated for word only and not for documents. Okay, so we have two documents in total, and out of which only one has this word call. So I'll say 2 divided by 1, and then I'll take log of it, which will give me 0.301. Similarly, I'll calculate it for every word. So let me tell you what is the benefit of using these things, term frequency and inverse document frequency. Let's talk about these two sentences. If there is a word which is appearing in all the documents that we have, for example, WhatsApp. So we have WhatsApp in both the documents. Then can we use this to basically categorize these two documents? Can it help in classification? If one thing is appearing in all the documents, I think we cannot use it for classification purpose because it is common everywhere, right? So what are the other things that can contribute? So I think it is call, which is important, which is giving me, which is different in this document. And in this document, we are not discussing about any call. So here, person is saying, call me on WhatsApp. Maybe he wants to discuss something suspicious. I don't know. But here we are talking about WhatsApp. Here we are talking about WhatsApp. I think we cannot use WhatsApp as a feature. I mean, WhatsApp is not giving me much, but other values can contribute more. So from this thing, the inverse document frequency we are calculating, it is just telling us, I mean, how rare that word is. So here it has assigned 0 for WhatsApp. It means it is not useful for this classification exercise. Maybe other words are more important. So with TF-IDF, we are assigning weight to words based on their importance. However, in other two exercises, we were not doing that. So they were, I mean, even in first one, it is just telling us whether the document exists or not. That's it. It is just telling me the frequency of word. But here we have assigned some weights, some significant weights that can give us like better understanding of the data. Is it clear to everyone? Let me know if you want me to repeat or if there is anything which is not making sense. Cool. Ring casing is fine. So for this exercise, I mean, you can get Python code from anywhere on the internet, but the important thing is we understand these concepts. I mean, why TF-IDF and why not bag of words or binary term frequency? What is the point of using TF-IDF? We need to understand this. So this is all. So we have covered data collection, data cleaning. Yeah, we are removing stopped words here. Train test split. Yes, we have covered. We'll just split our data set into 80-20 ratio. So we'll train our model on this one. So we have transformed our data using TF-IDF. So once it is transformed, now we can apply any machine learning algorithm, right? So this is what our overall workflow looks like. Now let's go to some code. Okay. So we'll try to train a model. In this session, I have already created a small data set for you. Okay. I'll remove all other things. Okay. So this is a very, very small data set. I mean, training a machine learning model on only on this data set doesn't make sense, but for your understanding how the overall process works, so I have created this data set. So I have a sender, I will call you on WhatsApp. So my review team has labeled it as context true because they see some risk there because someone wants to discuss something, I mean, privately and not on office phone. So there could be some risk. And in another sentence, they are saying, let's discuss offline. Again, I mean, same thing, something suspicious here as well. And my data team or reviewers team has labeled it as true. Yeah, there is some risk. In next sentence, they are saying, hi, how are you? WhatsApp has released a new update. So here they are discussing WhatsApp, but they are not discussing anything that is suspicious. I mean, they are discussing, oh, WhatsApp has released a new feature, which is cool. I think that is fine. I mean, I don't see anything suspicious here. So they have tagged it as context false. I mean, nothing risky. Next sentence is my phone is not working today. Again, it has nothing to do with risk. Again, context false. Next sentence, call on my personal phone. Maybe they want to discuss something. I don't know what, but again, I mean, I see some suspicious activity here. So they have tagged it as true. In next sentence, they are saying, I'll adjust it for you. But we are not sure what adjustment they are talking about. Then maybe after reading entire email, the review team found that they are not discussing anything suspicious, so context false. Next sentence, I will adjust price. So this is price manipulation. So this is something suspicious. This is a red alert, I believe. So they have tagged it as true. WhatsApp has launched a new feature. Again, nothing to do with this. Context false. Next sentence, you can send message on my phone. Yes, I mean, there can be some risk. Context true. He has denied to adjust the price. So here again, they are talking about price manipulation, though the agent might have denied, but still, I mean, something suspicious that we should review. Yes, context true. So this is my training data set that I would like to test, train my data set on. Again, I mean, it's a very, very small data set and I'm not expecting my model to achieve give some high accuracy here. So, but this is to give you an idea, I mean, what kind of data set we are dealing with in this project and how did we solve it. Okay. Let's move to the code base. So I have already written some code as it will be very difficult to write it this session, but I'll take you through line by line. So forget about this for some time. So I have imported some libraries here for modeling TF-I, IDF thing that we discussed. So we don't need to calculate this term frequency, inverse documents frequency. I mean, we don't need to write our own program. So we have some libraries that can do it for us. So we don't need to write it. So if we have something ready-made, I think why we write code? I mean, it will save us a lot of time. Similarly, for modeling as well, we are using randomized search. Let's discuss it later on. Yeah. Okay, I'll start from here. So these are just library. We are importing some libraries for model training and evaluation purposes. And here, from line 20 onwards, I'm just specifying the columns that I'm going to use in my script. So in my data set, I have a column called call ID, so which is my unique identifier. Then we have a data column that we'll be using for our model to train on, which is text. Then we have a label column, which is context, which is my target variable as well. Again, so we have a variable called target that I'm saying label. So currently we don't have any column called label. but we are going to create it. So for model training purpose, we cannot use text data like context false, context true. We need to convert this into numbers. Although this is my label column, but we need to binarize it. So we'll convert it into 0 and 1, and we'll name that column as label. And now that will be my new target column, right? Okay, let's run the program. I'll debug it line by line so that you understand what we are doing here. Okay, so in this line, I am reading the data set from the drive. This is my data set. Okay, I'll run this line and see what this variable has stored. View as data frame. Okay, yeah, I can see it has all the columns that we have in our data set and all the rows as well. Yeah, cool. So this is my data frame. So this is a data structure in Python, widely used. So, and as we discussed, we cannot use our target variable as is. We need to convert it into numbers. So we are going to create a column called label, and we'll tag them as 1, 0, 0, 0, 1, 0, 1, 0, 1. Yeah. And I am doing this in this line. So I'm creating a new variable, new column called target. Target is my variable where I stored this string label. Label binarize is my function. It's an inbuilt function. I can use this to binarize this column. Let's run this line and see what does it return. So we will again check our data frame, whether it has the newly added column or not. View as data frame. Yes, it has added one column. 1 for context true and 0 for context false. Correct. So this is what we wanted to do. Next step is to split my data set into train and test. Okay. So in this line, so again we are using a library and that has a function called train test split. Here I can specify the percentage. So here I have specified 0.20. It means my test data set will be 20% of the entire data, and rest 80% will be my training data set. You can see another variable called random state here. So in this variable, we can pass any number of your choice. So basically, when it is splitting data into 80-20%, it randomly selects those records. But if you don't pass a random state and you run this line again and again, so every time it will give you different set of records. But if you want to return the same set again and again, I mean, every time I run this line, I need same training and same test data set. But it will help me understand, I mean, what was my test data set if I have made some changes in train. So you can pass any number here, 100, 42, whatever you want to pass. So you can pass any number, but that will be constant. So every time when you run this line, it will give you same split and not a different data set again and again. Okay. I think, okay. So in this, so now I have trained data set, test data set. I think now I can remove data frame. This, I'm not going to use it again. And why do we need to do this? So here in this case, we have only like a couple of records, maybe 10 records. But when you are working on a live project, so you'll have records in millions. And these data structures will consume a lot of memory. I mean, you'll not have enough size for model training. So you can keep removing or garbage collecting. So I'm removing this. I mean, as a best practice, I'll remove this. And at the same time, I'm using garbage collector, which will release the space that it might have taken earlier. Okay. Okay. Next, in this step, what we are doing is, so now in our data frame, we have 4 columns: call ID, text, context, and label. So we don't need that column context anymore. So we just need label. So we can remove that. And since we might have like a lot of columns in our data set, so we'll just focus on what we need. So I have kept only these 3 columns that we need, and I have stored them into a variable called merge columns. And then I'm creating my training data set. So in train DF, we had all the columns, but in new training set, we'll have only the ones we are interested in. Yeah, we have label, context, everything, but in it, absolutely, yeah. Context will be removed. Like call ID, text, and label. That's fine. Again, it's to reduce the size in memory. Releasing size in memory. Again, since we have a new variable called new training now that we'll be using for model training, train DF is of no use now, so I can remove that as well. Private collection. Here I'm doing some logging, just for future perspective. Okay. Similarly, as we have now 2 different data set, test and train, I am performing the same exercise on test data set as well. I'll filter that for columns. Yeah. Okay. So in new training data set, if you see the leftmost thing, which is my indexes, you will see some random indexes as it has randomly selected data from the data frame, actual data frame. So it has picked first record, then 5th, 4, 2, 0. And I want to reset all these things from 1 to, whatever. Then if you want to do it, then you can use this function, reset index. So when you run this line, so all the indexes will be reset and they'll start from 0, 1, 2, 3, maybe. Yeah, 0, 1, 2, 3, 4. So this is just for readability perspective. So we have done this. Okay, in next line, I am defining a scoring function. Basically, on which metric you want to evaluate your model. So I want to evaluate this on ROC AUC score. So this is a standard syntax that you need to write to create a scoring function. So my scoring function will be C score, and to create this function, I'm using a function called make a scorer. And here I am defining the metric that I need. So I want to use ROC AUC score, then ROC AUC score. Greater is better means if ROC AUC score is greater, then my model is better. Then needs proba is basically what do you want to return from the model, probability or labels? Do you want 0, 1, or do you want the probability of being 0 or being 1? So here I want probability, so I'm writing needs probability equal to true. Okay. Let's move on to next line. So what was our data flow? Data collection, yes, we have our data set. Data cleaning, we haven't done it yet. We'll do it when we create. So here we have changed it a bit. We have done train test split first, and then we'll create the vocab. So we are done with data collection. We are done with train test split. Next step is to convert our data into structured data and data cleaning. And we are going to use PFIDF here. So for this, we have an inbuilt function. So for this, I have a library called scikit-learn. So I have installed this library scikit-learn, and from this library, I'm importing this function df vectorizer that will do the job for me. I mean vectorization that we discussed. Okay. Okay. The important thing. Okay, let's discuss other things first, and then we'll discuss this parameter. So we discussed about stop words, right? So we want to remove stop words from our documents as we don't think that they'll contribute in classifying our model, our documents. So we are using, so when I say stop words equal to English, it means they already have this, I mean, this library already has a dictionary for English words. So it will use that dictionary. Maximum features. So the example we were discussing, what was the example? Yeah. Okay. So this is, so these are my number of features, 1, 2, 3, 4, 5. So in our case, we had only 5. And as our data set is also small, so we'll not have more than 20 or 25. But there can be a case when we are working on large corpus that we may have our features in millions or billions. So if you want to limit them, so 100,000 is, I think, a standard number that you can use for this. So here I'm using 100,000 as maximum features, but in our case, it doesn't matter. We could only say 100 or whatever. Right. We were discussing about this one, n-gram. Okay. So this variable is, okay. So when we created features, so these features for building these features, we took only one word, call, WhatsApp, launch, new, feature, cool. But to understand the overall context of the sentence, you might want to use a combination of words. For example, let me give you a sentence. I say, I do not like it. In another sentence, I say, I like it. Right? Both the sentence has different meanings. But if I use only one word for feature, I mean, I might not understand the overall context. But if I use a combination of two words, for example, I say not and like together. So it will help me understand the context. I mean, here the person is not liking the thing, right? And then I say like it, right? So to understand the context, we can create a pair of more than one word. And when I say n-gram equal to 1 and 2, it means I want to create one word as a feature as well as a pair of two words. So in this case, if I say n-gram equal to 1 and 2, so my final data set will look something like this. Call, WhatsApp, and since launched, these were part of different sentence, they'll come something like this. Launched so it will be removed, then I think it will be just launched and new, then new feature, something like this. We'll have these one words as well as pairs. Guys, am I making sense? Is it clear to everyone? So the model that here we are building is to understand the context. And as creating pairs for features will help me understand the context better. So we are using this ngram. So you can, and it, I mean, it depends. I mean, sometimes we don't need to create, we don't need to take pairs. I mean, it's not always the case. On some data set, we just need one word. And some data set, we might want to add like 3 words, maybe. I mean, it depends. So you can start with 1 and 2, and then can try with just 1, or 1, 2, and 3, and then you can go with the one that works for you. And how do you know that this one is working? Based on model's accuracy. Okay. So we have a TF-IDF vectorizer. Now we have set some parameter values. I mean, how many maximum features will be, what are stop words. So you can add your custom list as well. So here we are using the inbuilt dictionary of English words for elimination of stop words. But if you want to add more words in this, then you can pass your custom dictionary. For example, you can create your own dictionary stop words, or whatever you want to call it, or array, and then you can pass this dictionary here instead of stop words. Okay, I think we are good with this one. Okay, we can remove this. Some features TF-IDF. Let's run this line and see what does this line return. Okay, so I have run TF-IDF on my dataset. I have fit this on my training dataset, and I want to check what is my vocabulary. So it has created these features. So it has created a feature called adjust, but as we have passed ngram as 1 and 2, so it has created a pair with price as well. Since denied, adjust, discuss offline, hi, what's up, let's discuss, message phone, new update. So this is my list of features. So this is basically this is my vocab. So TF-IDF has created this vocab for me after removal of stop words and creating pair of words. Okay, we have the dictionary now. Now I want to transform my data set. So in this line, I am transforming. Basically, in this step, I am assigning scores to these words. Let's see what it is return. What does it return? Cool. Okay, so it is not in the form of matrix, but it is telling me, so 0, I mean the word which is on this index has been assigned this score. Let's see what is my TF-IDF dot vocabulary, and see what word do we have at location. So 14. So first 0 document, and its number is 14. So it has been assigned 0.44. I don't know how it has assigned these numbers 14, 8, 4 to these words, but we can check what is the value for this word. So for offline, its index is 14, or let's check for WhatsApp. So its index is 27. Index is 27. You check. So here 0 is my document number. So we have only 8 documents. So it is in third document. So 327. So it has been assigned 0.33. So this word has more importance. So word which is at index 16 has more importance than this word. Got it? So TF-IDF has created this thing for me. So we are at this step now. Okay. Next thing that, as we discussed, is modeling, and at the same time we want to tune the parameters that you pass to your modeling algorithm. So in our case, we are using SGD classifier. So instead of random forest logistic regression, we are using SGD classifier. This is nothing but logistic regression, but stochastic gradient descent running in the background. So it's again one algorithm with, I mean, for modeling. So I'll not go into the details of this. So we already have a function for it. So you can use this inbuilt function SGD classifier. And for SGD classifier, we have two parameters: maximum iteration and learning rate. So we need to find optimal values for these two parameters. And for this, we will use random search. So what will happen is, so we will pass a range for these two parameters, maximum iteration and learning rate, and then we will pass the entire model to random search. So it will create a combination of these things. Maximum iteration and learning rate will build like hundreds of thousands of models, and the model with the best score will be returned in the end, right? So in terms of to understand maximum iteration and learning rate, so here we are using stochastic gradient descent. So it is basically about, so let's say you are standing at one point and you wanna, so everyone, I mean, use the standard example. Let's say you are on hilltop and you want to climb down, right? So so at one point, so you'll take one step, and you will see whether you are going up or going down, right? So you'll have to take a step. So maximum iteration is how many steps you will take from that point. I mean, in all the directions. I mean, I'll take a step in all the directions, and how big that step will be. I mean, I'll jump or I'll just take a small step. So that, I mean, the range of that step is called learning rate, and the maximum, how many steps I'll take in all the directions from that point, is called maximum iteration. Okay, so these are my parameters that I want to tune in. One is maximum iteration. Here I have passed a range. So I'm using the inbuilt function SP randint. So it will create a random numbers between these two numbers, 1 and 100. Then alpha is my learning rate. I mean, next parameter, so it's my learning rate. So here I'm passing a range from 0.1 to 1. So it will increase 0.1 at one time. So these are the two parameters that I want to tune in. And these are some other parameters that I have already passed values. So SGD classifier, I want to use logistic regression. So I am using my loss function is LOG, it means logistic regression. Penalty, L2 random state. Again, I mean, similar to what we discussed earlier. I mean, you can pass any number, whatever you want. You want to shuffle data, yes. Learning rate, optimal, average, class weight. I mean, this kind of things. Standard parameters. I mean, you can have default values for all these parameters, and just you might want to tune just these two variables, right? And since it will create, so if I talk about the combination of these two things, it may create like thousands of or millions of models, but I just want to have like 10 models from that range. That's it. And I want to select best from those 10. So that is that number, and iteration search. So from this range, I just want 10 randomly selected values and models, and just want to test how they are doing. Okay, so this is my modeling algorithm, and this is for my, and these are parameters I want to tune, and then these. So here I'm just passing some variables. It's of no use. Number of folds. So this is my random search algorithm. So you can use grid search as well. So random search is faster as it doesn't check for all the combinations. It'll just randomly select values and create some models. So I'm using randomized search. So when you have a large data set, use randomized search instead of grid search. But if you have a very small data set, you can use grid search as well. Okay. So from this line, as we discussed, so it will create models for combinations of those parameters. And in the end, it will return a model with best score. So here I am returning the best score that we will get for this data set. And these are the and it will return the parameter values. I mean, the best parameters. I mean, the parameters for which it has scored, achieved that score, best score. And then here I'm transforming my test data set as I want to test my model's performance. And yeah, so here I am returning probabilities. Basically, it's part of model evaluation now. So our model training is done till here. So we have trained our model till line 90. And after that, I'm testing my model's performance on test data. And so to pass test data to the model, so we need to transform our data set using the same TF-IDF, meaning same vocabulary we have extracted from training data set, and then we'll pass it to the model and we'll check how our model is performing. Here I am storing the output. Here I'm calculating different metrics. Let's forget about it. I think we can use this. So here I'm using confusion metrics. I mean, how many positives were there in the test data set, how many it has identified, how many positives were identified as positive, how many positives were identified as negative, this kind of things. Okay, so our data set is very small. Let's add more rows. I'll just replicate this. Okay, so this is my training set now. I'll run this program again and I'll stop it after model training, and then we can run it step by step. Okay. Okay, so we were trying to find optimal values for alpha and maximum iterations. So the best score that it has got on this data set is 1. Wow, very good score. And so the optimal value for alpha is this very small value, and maximum iteration is 14. So at one point I will take 14 steps in all the directions with this much range, whatever value we have received for alpha, and then it is saying, and I'll be able to climb down from the top in minimum time or minimum efforts. So this is how you can interpret this. Okay, let's see what it does with our test data set. Test data set. Okay, we'll see. Let's see. I mean, what is the output that it has returned? Test data set. 0, 1. Okay, so the actual label in the test data set for this document was 1, and our model is saying probability of being 1 is almost 1, which is good. Actual label for this document, the second document, is 1. I mean, context was positive for this document, and our model is also saying that it is 99.6%. I mean, 99.6% probability of being 1, which is again very good. Actual label for 1, this document was also 1, and our model has also given it 99.99, which is almost 1. So all the three documents that were labeled as context true in our test data set has been identified. I mean, our model has given almost 1 probability of being 1. I mean, context positive, which is very good. And these three documents were labeled as context false, and our model is also predicting them as false. I mean, probability of being 0 is 1, 1, and this is 1. So our model is doing fantastic job. However, I was not expecting this to perform at this level because our data set is very, very small. Correct? So this is the output we are getting. Let's run next command. Okay. Let's see what we are getting in confusion matrix. So this is how our confusion matrix looks like. So it is saying 0, 1. Where is actual? I think I need to run it from somewhere else. I'm not able to interpret what is it saying. Wait, matrix. Data frame from dict orientation. I think it has saved matrix as well for us. We'll see, let's see. Yeah. So from the matrix, we understand 3 true positives. It means 3 documents were labeled as positive in my test data set, and our model has been able to identify all 3 as positive. So which is very, very good. False positives, false negatives, both are 0. Great. True negatives. True negatives means in our data set, we had 3 documents labeled as context false, and our model has been able to identify them as context false, which is again very great. So our model is doing pretty good, and as per this, our model's accuracy is 100%, which will not be the case. I mean, when we will work on real data set, when you, I mean, if you get accuracy around 80%, that is supposed to be a very good accuracy. I mean, you'll not get better than that accuracy, I think, in real time scenario. Okay. What else? Yeah. So whatever model we have trained, we can save that as well. So I have commented these lines here, so we can store that model in your repository, and whenever, and to deploy this in production, you will keep it in some repository. You will create a batch script or a shell script to call that model. It depends. How you wanna deploy your model. You can have your data set in SQL, and you can read if new data has been added to the table, then you'll trigger your model and score those documents, something like this. It depends. How you want to deploy a model and how what the client's infrastructure look like. Based on that, we can do it. I think that is it from my side. I hope I made sense. And if anyone has questions, please let me know.
Any questions, participants? It was really a wonderful session, Aditya. The practical exposure to all, and maybe they will be sharing this knowledge with their students also, and tell them how important it is to work on text classification and entity recognition. So, any questions?
So this is one of the areas. All the organizations are focusing on these days, and has a lot of scope. For students as well. And next big things in line are image and video processing. Some companies are working, but we don't have enough. At least in India, we don't have enough video data or image data that we want to process. But we have a lot of text data. Even in colleges as well. Emails, chats that we want to process. We want to fetch useful insights. So I think it has a lot of scope for the students if they want to pursue this line.
So I think it's all done. Thank you, sir. Thank you for your valuable time you have given and your knowledge you have shared with all of us. It was really a very wonderful session. Thank you. Thank you very much.
Thank you very much.
Students, so the next and the final session will start at 2:30. The details have been shared on the group that you will be having. A link will be shared